In the previous section, we have discussed how to use regression lines to carry out estimation, or prediction, of values for a variable. However, how valid this procedure is in carrying out estimation depends on the assumption that a linear model is a good fit for the data we are given, and this assumption does not always hold. For example, the scatter diagrams as shown on the screen illustrate how different sets of bivariate data may demonstrate different possible relationships between the two variables. While the scatter diagram can show clearly if a linear model is a good fit for the data, this may not always be a practical approach to determine the degree of linear correlation between the two variables, especially when we are dealing with a large set of data. In this case, a possible alternative to using the scatter diagram would be to use a certain measure called the product moment correlation coefficient, R, which can be calculated by using either one of the two formulae as shown on the screen. Note that both formulae can be found in your MF15 formulae booklet. The product moment correlation coefficient gives us an indication of the direction of the correlation, and the strength of linear correlation, for the set of bivariate data. If the product moment correlation coefficient is positive, then the two variables are positively correlated. In other words, y increases in value as x increases. If the product moment correlation coefficient is negative, then the two variables are negatively correlated. In other words, y decreases in value as x increases. The closer the absolute value of the product moment correlation coefficient is to 1, the stronger the linear relationship between the two variables is. In other words, a linear model is a good fit for a set of bivariate data, if r is close to 1, or close to -1. Here are some other notes for the product moment correlation coefficient. 1. For any set of bivariate data, the value of r is at least -1, but does not exceed 1. 2. If r equals 1, then the set of bivariate data demonstrates a perfect positive linear correlation between the two variables. If r equals -1, then the set of bivariate data demonstrates a perfect negative linear correlation between the two variables. If a set of bivariate data demonstrates a perfect linear correlation, then all the points in the scatter diagram lie on a common straight line, which is both the y on x line, and the x on y line in this case. You can refer to the diagrams in page 13 of your lecture notes to observe how the two regression lines appear relative to each other for different values of r. Notice that the closer the absolute value of r is to 1, in other words, the stronger the linear relationship demonstrated, the closer the two regression lines are to each other. Also, note that the x on y line is always steeper than the y on x line. 3. R is a dimensionless quantity, in other words, it has no units, regardless of the units of each variable. 4. The value of r depends on the given set of bivariate data. Hence, it may change in value if more data pairs are added to the bivariate data, after conducting more trials of the experiment, or if a data pair that has been discovered to be an outlier is removed from the set of data. 5. On the other hand, the value of r is independent of any linear transformation carried out on the set of bivariate data, since the strength of linear relationship between any two variables is preserved after any translation, scaling, or reflection. For example, the value of r for a set of bivariate data for two variables, say temperature and amount of rainfall, will stay the same whether or not the temperatures are measured in Celsius or Fahrenheit, since the conversion from one unit to the other can be expressed as a linear relationship. F equals to 9/5 of C plus 32, where C and F are the temperatures measured in Celsius and Fahrenheit respectively. We will now look at an example which illustrates how we can use a graphing calculator to calculate the product moment correlation coefficient for a set of bivariate data. A set of bivariate data between two variables, x and y, are as shown on the screen. Calculate the product moment correlation coefficient, r, for this set of data.